The point P is on the unit circle. If the x-coordinate is 1/2 and P is in the fourth quadrant, what is the y-coordinate? Let's plot the point on the unit circle. Here's where x equals 1/2 on the x-axis, which indicates if we go down to the unit circle along the vertical line x equals 1/2 here, we can locate the point we're looking for. So this is the point on the unit circle where x equals 1/2 and the point is in the fourth quadrant, and we're looking for the y-coordinate. From here, let's go ahead and sketch the reference triangle for any angle in standard position where the terminal side passes through this point. This will give us the hypotenuse for the reference triangle, which should be this segment here. And now we'll go ahead and sketch the reference triangle. We know x equals 1/2, so we can label this side 1/2. Because we're on the unit circle, the hypotenuse is 1, and this vertical leg would be y. We can now determine y using the Pythagorean theorem, which for any point on a circle, center of the origin is x squared plus y squared equals r squared, but because we have the unit circle where r is equal to 1, we have x squared plus y squared equals 1 squared, where 1 squared equals 1. This indicates that the square of 1/2 plus y squared must equal 1. And now we'll go ahead and solve for y. First we'll square 1/2. The square of 1/2 is 1/4. Next we'll isolate y squared by subtracting 1/4 on both sides. 1 minus 1/4 is the same as 4/4 minus 1/4, which is 3/4, giving us y squared equals 3/4. Algebraically, we'll have two values for y, a positive value and a negative value. The positive value would be the y-coordinate if the point was in the first quadrant. The negative value is the y value we're looking for in the fourth quadrant. To get both solutions, we take the square root of both sides of the equation and include a plus or minus on the right. Simplifying, the square root of y squared is y equals plus or minus the square root of 3 divided by the square root of 4. Square root of 4 is equal to 2, giving us y equals plus or minus the square root of 3 divided by 2. And again, we're looking for the y value in the fourth quadrant where y is negative, and therefore we have y equals negative square root of 3 divided by 2. Notice the point on the unit circle is the point 1/2 comma negative square root 3 divided by 2. And recall in the unit circle, x equals cosine theta and y equals sine theta, which indicates for any angle in standard position whose terminal side passes through the point P, the cosine function value is 1/2 and the sine function value is negative square root 3 divided by 2. I hope you found this helpful.